going on, everyone? Trey with Modern Ed here, and today I'm here to teach you about simplifying radicals and writing them in exponential form. Radicals are a way to basically write irrational numbers as accurately as possible, or I should say some irrational numbers as accurately as possible. Not even as accurately as possible, just accurately, actually. And not only that, it's also the only way to write them correctly. And so a lot of times kids have problems writing them going from radical form to exponential form, or just simplifying them because they kind of forgot the properties that they learned in maybe 8th or 9th grade, and they kind of come up in algebra or trigonometry or geometry or maybe even sometimes in calculus, and they're easy to forget. And so I'm here to help you out with that. Let's take a look at some. To write a radical as an exponent, all you need to do is just raise the radical to the reciprocal of the index. So this right here is your base, and right here is your index. And then this is what it looks like afterwards. And that kind of looks like, again, like kind of formulaic. It might not make the most amount of sense, but once you actually try it out a few times, I promise this makes sense. So let's take a look at our first problem, just the square root of x. This is also often written as the root of x. So if you ever see the root without any number, without any index, it's assumed to be 2, okay? And so think about this. Another way to write this is x to the power of 1. And so remember what I was talking about with multiplying by the reciprocal of the index. Well, if this is our index here, 2, the reciprocal would just be 1/2. So I would have x to the power of 1 times 1/2. That's going to give me 1/2. That's it. That is how you write the root of x as a fraction, a fractional exponent. How about the cubic root of x squared? Well, again, I'm going to have x squared. My index is 3, which means I'm multiplying by the reciprocal, which is 1/3. That means x is 2/3. Done. And now let's try one that's slightly more complicated. Let's say I have 3/4, and I have the root of x to the 5/9 y to the 3rd. Okay, so remember that each and every term is going to be taken into account when we are multiplying this reciprocal. Because really what it is, and this goes back to our last video, which in case you missed it, go ahead and check the link in the description. It'll help you out with this part. So what I'm going to do is I'm going to multiply each of these powers by the reciprocal of the index. So I'm going to have x to the power of 5/9 times 4/3 times y to the power of 3 times 4/3. Okay, so each and every power is going to get multiplied by the reciprocal of this index. And now all I have to do is just simplify. So I have x, let's see here. And you know what, maybe I would have been better off writing this a little bit clearer as 5/9. So I would have 20/27 times y to the power of 4. And that's it. And it's just that simple. That's how you go from radical form to exponential form. So now let's take a look at how we actually simplify radicals. So right here, I have the 4 steps. Maybe you want to pause the video and take a screenshot of this just so you can reflect back on it when you're doing work on your own. But I'll go ahead and read through them. You really want to find the prime factorization of each number under the radical symbol. So underneath the radical, you want to break each and every number down into all of its different factors. Then you want to identify the set of factors that are same and group them together. We'll go over that in just a second. And then for each set of those factors, you're going to remove one from under the radical as indicated by the index, which is the number in front of the radical, and write it as a single factor outside of the radical, and then multiply all the factors outside that radical together. That sounds really confusing, doesn't it? I don't blame you. However, you'll see that once you go through a couple sample problems, you'll actually see steps 1, 2, and 3 and 4 just kind of happen organically and happen naturally, okay? So don't feel like you have to put these on flashcards and memorize them. That's not really going to get you anywhere. What I would do is just kind of keep them in the back of your head, go through some problems and go through the motions, and then look back at these and be like, oh yeah, actually that was step 1, 2, 3, and 4, and that's how we solved it. Okay, so let's take a look at an easy problem to get us going. So here we have the square root of 50. So let's break these up into all the possible factors. And like I said before, if there is no number written on the outside of the radical, if there's no index, it's assumed to be 2 because you are assumed to be taking the square root. So let's go ahead and take the root of, how do we break up 50? Well, we can do 50 and 1. That doesn't really get us anywhere. We can do 10 and 5. We can do 25 and 2. It doesn't really matter. But I'm going to go ahead and choose 10 and 5. Remember, it doesn't matter because you're going to end up simplifying it all anyways. Then 10 I can split up into 5 times 2. And then 5 is going to be just 5 times 1, but that doesn't want to get us anywhere. So let me go ahead and just for this example, just to show you, I'm going to group the like or the same numbers together. Okay. Now remember, each and every step here, I'm taking the square root. So this is what I was talking about removing one of the numbers when you see the a pair or a triplet or whatever it happens to be as indicated by that index. So what I mean is, since I'm looking for the square root of these, I am looking for 2 of the same numbers, and I'm going to take out 1 and put it on the outside. That's what that means. So since I have 2 5s here, I'm going to write 1 5 on the outside, then the root of 2 times 1. And you know what? 2, that's just 2 and 1, that's a prime factor. And then 1, that's a prime number. So I am going to be left with 5 root 2, and that's it. Okay, so if you go back to our first 4 steps, you'll notice that we actually did each and every one of those steps, and we ended up at the answer. And it's going to work for us every time, no matter how complicated the problem is. Speaking of which, medium problem. All right, so here's our medium problem, and for some reason it's larger than the other one, but whatever, because it's medium sized. But either way, we're looking for the cubic root of 8x to the power of 30. So let's break this down. Let's find the prime factors of 8 first. So I can break up 8 into 4 times 2. And let me just keep x to the 30 right here for now. I can break up 4 into 2 times 2 times my other 2. So again, that 4 splits up into those 2's. There's my other 2. Then I'm going to have x to the power of 30. Now, forgot one of the most important parts, the cubic root. So I'm looking for 3 numbers on the inside of the radical, and I want to pull out one of them to the outside. So since I have 3 2's, one of them is going to come out to the outside. So I'll now have 2 times the cubic root of x to the power of 30. Well, I'm not done yet because I can still simplify x to the power of 30. So I'm going to have 2 cubic root. Let's break this down into, I don't know. Let's say x to the power of 10 times x to the power of 10 times x to the power of 10. Kind of a little bit of a shortcut just because I know what the answer is. But you can see that if we actually broke this up, I have 3 of the same exact things here. Okay? Because remember, x to the power of 10 times x to the power of 10, that'd be x to the power of 20. Then x to the power of 20 times x to the power of 10 would be x to the power of 30. So I know that I now have 3 of the same things inside the radical, so I can pull out one to the outside. I'm now left with 2 x to the power of 10, and that's it. But of course, things can always get a little bit more harder, which leads us into a little bit of a harder problem. Okay, so now I'm taking the 4th root of 1,296 x to the power of 28. So it might look pretty intimidating, but if you just follow the same exact steps, break it down, find the prime factors, look for the number, look for the same number as you have here, 4, and then pull one out, and then just keep going until you're simplified as much as possible. There's nowhere else to go, and you'll have your right answer. So let's give it a try. So first things first, let's go ahead and let's break down 1,296 down into its factors. And so a lot of times when you get a really big number, you might be tempted to guess and check on a calculator, divide by 3, divide by 4, divide by 5, divide by 16, and just hopefully you get 2 whole numbers and you can write those down. But one method that you can use, it is the longer one, but it still will get you the right answer, is that if you have an even number, you can always divide by 2, and then you can break your factors up like that. So let me actually go ahead and do that. Let me divide 1,296 by 2. So I'm actually going to get 2 times, that's going to be 648 times x to the power of 28, the 4th root. Then I have the 4th root of 2 times, well, look at that. I have yet another even number. I have an 8. So I can break this down into another, divided by 2 again. So I have 648. That'll be 324 times x to the power of 28. Then I'll have the 4th root of 2 times 2 times, well, again, 324 is going to split up once again. That's going to be 162 times x to the 28th. And I'm still can keep going because this is still even. 2 times 2 times 2 times 162 is even, so times 2. But then what is 162 going to be? That is going to be 81, x to the 28th. So now I'm not exactly stuck, but I can't divide by 2 anymore because 81 is an odd number. But if you see, I have 1, 2, 3, 4 2s. 4 is my index, so let's pull out a 2 to the front. That means I'm going to have 2 times the 4th root of 81 x to the power of 28. I can still keep breaking this down. So let's think about this. If I have 2, and I'm taking the 4th root, well, 81 can be split up into, let's do 9 times 9. 9 times 9 is 81 times x to the power of 28. And by the way, you can break up x to the power of 28 now if you want to. I'm just doing it as, I guess, as slowly as possible. This is probably the most inefficient method, but it might be the best way to explain it. So let's keep breaking up my numbers instead of my variables, and that might actually kind of help you see the patterns here. So 4, 9, and 9, that can be broken up into 3 times 3, and then 3 times 3, because 9 is 3 times 3. This 9 is 3 times 3. There we go. Then times x to the power of 28. And look at that. I have 1, 2, 3, and 4 3s. So that means I'm going to have 2 times 3 times the 4th root of x to the power of 28. That's going to give me 6 times the 4th root of x to the power of 28. So now, let me rewrite this so it's a little bit clearer. So I have 6 times the 4th root of x to the power of 28. Now you might be thinking, okay, how do I break up 28? And there's actually an easier way. And if you missed our last video, check it out. The link is in the description, but it goes over exactly how to convert this into a fractional exponent. And you'll actually realize that this is one of the easier ways to do this. So if we have 6 right here, I know that I'm going to multiply by the reciprocal of my index. My index is 4, my reciprocal is 1/4. Now look at that. I have 6 times x, 28 over 4, and that is going to be 6x to the 7th, and I'm done. That's my final answer. So you can see it can be a little complicated, but I promise as long as you practice, you can really get a feel of how to break the numbers down into their prime factors, and then know what your index is, and then move one out once you find the number inside the radical that is matching your index. And then you can also just use your property of fractional exponents and divide and multiply, and you'll eventually get to an answer. And no matter how complicated these get, the process always remains the same. The only issue is that the margin of error increases. So you want to really make sure that you're being careful, use your calculator if you're allowed, and just work slowly and step by step and just be patient. Okay, so I hope that you found that useful. Drop a comment down below if you have any questions. I think we have like 5 views per video. So basically, if you leave us a comment, you're gonna get like free homework help, free tutoring help. Isn't that a great deal? Yeah, so hit the like button, subscribe, and we'll see you guys in the next one. Take it easy.